My friends, welcome to this week's weekend special. This week I'll be building Model Mania 2012, and let's take so before we go further, this is the website that I am practicing my skill on FreeCAD. These are properties of SolidWorks, and I have built some of them, and today I want to work on exercise Model Mania 2012. So the idea is I'll have to build this model, and then this is phase 1, and then modify this model to build the phase 2, which looks like a simple lever and with two cylindrical holes here. Now on the phase 1, the lever, the handle is a little shorter, and the holder is kind of longer. In the phase 2, the handle becomes longer, the holder becomes shorter. So let's go ahead and give it a try in FreeCAD. I will be using 0.22 version of FreeCAD today. And let's go ahead and import the image, the technical drawing, and I want to start by processing the technical drawing. All right, and now make it half transparent. I want to keep it from, so let's keep it on XY plane so I can work off this top view. So this is my first sketch. I want to relocate the image to help me draw that sketch. Now what I want to do is I want to take the center of the sketch at this point. Okay, let's do that. So let's bring it in the middle and align it with this axis. Perfect. Let's take the x-axis away from our view and then start sketching on XY plane. Okay, so we have the sketch half top down, and I want to extrude that so we will need from this point to that point, which is more than 30 obviously. So let's go 50, and let's go symmetric, see how it affects. Okay, we got that. Now I can go ahead and mirror it over on this against this plane, which is XG, and then make it one piece and rename that as, say, top down. All right, now we have to draw this face from this XZ side. So let's go ahead and change the plane for the image and XZ and hide this for a minute. Bring the axis cross back and relocate this image to this center. Thinking about this, I may have to update the extrude parameters on there. So let's bring it back. See, the extrude is not covering the whole face. So let's go find that extrude, make the symmetric false, see where it takes, right? And add something in the reversed, say 15. So now it covers the whole thing. As long as it's covering both top and bottom, we're fine with it. Right, now we can hide it back and work on this sketch. So it would be another sketch on XZ plane and draw this outline using the polyline. We have the outline all constrained. Now what I have to do is I'll have to rename that sketch as side. I'll have to extrude that enough so it crosses this top down sketch. So let's say 30 and make it symmetric and hit apply. So it is crossing. Now what we should do is to actually do a Boolean operation. So take these two and do a intersection, and that gives us our phase 1 object. Very simple. What it does is takes the common part between the two parts that we developed and keeps it, deletes everything else. So we have few fillets to go around. So this is 2mm fillets all around, and it should be easy. Let's take this edge, this and this, and apply 2mm fillet. So it is applied all across, right? So we have to apply on this one as well. I am thinking maybe I should go back to the fillet and add this line and this line as well. And write 2, hit enter. We get that. And make another fillet for these two with 2mm. Oopsie. Okay, so what's going on here is that 2mm is not blending. It's not taking it kindly. The 2mm fillet here is not that big of a deal, but let's see if we do these two fillets first. See if that helps. Okay, now we have that 2mm fillet applied in here. Now I can go ahead and take these two and these two and say apply another 2mm fillet. Okay, so it's either of these. Right, that's a bit dramatic, I must say. So what is going on is we have on this dot, on this point, we have 3 lines coming in, and that is the complexity that FreeCAD cannot handle. But if we make that 1mm, that's okay. How about 1.99? Nope, it didn't work. We select these two, right? And maybe these two. Let's say 1.5. That worked. So we cannot apply 2mm, but we can apply 1mm fillet. Okay, so phase 1 is done. Let's switch our attention to phase 2. Phase 2 is on XZ plane. Place it, and now let's see what we have to do. We have to make this handle a bit more prominent. So I want to actually bring it back to XY plane and maybe do some calibration. I want to say this is, so the base distance between these two centers is remaining the same, and this technical drawing is came auto calibrated. Very interesting. All right, and how about the axis cross? So we set the axis cross in the middle of this center line. We should keep that uniform on this drawing as well. Cool. So first of all, we'll have to update. So I'm gonna go ahead and save this as phase 1. In phase 2, first task is to find that original sketch top down and see where it fits. So we'll have to make this 65, 85. So let's make it 85, right? And that should change this value to 24. Okay. Right. And I think that's it. Okay, this is 20. We have that 20. And nothing else changes. Interesting. And just we keep it like that. Now this is broken because, okay, let's take those fillets away from our side. So now this is what we have. I wish that would be the end of our job, but I see here that is this cylindrical hole. It comes as a hole, and the easier job actually is to make a tube and then do it right there, right? So what I want to do is I want to make it quick. I want to create a tube of diameter 9. Outside radius would be 9 and inside radius would be 4.5. So let's create a tube. Outside radius is 9 and inside radius is 4.5, and then the length would be 24 exactly. So we got the tube, and I want to make it like lay it down sideways, okay, and push it back. We'll verify those values from the placement tab. In position, the y would be half of 24, and then on x side, on this side, it would be this distance 24, so x would be minus 24. Okay, so that made it quick. I mean, all we have to do is make these two a union, and that's our object without the fillet, obviously. So I wonder if we will be able to do the fillet at all here, because it has, this point has 3 lines coming in. It might be an issue. How about we give it a try anyway? So we have 2 millimeters fillet going around everywhere that we can think of, and I want to try these 2 edges first. Let's make 2 millimeter fillet in there, and it fails instantly. How about we make 1.5 millimeter? Should that work? Okay, so that approach is failing. Now, what if we took care of the other fillets first? I'm gonna go ahead and select this object and go to fillets and select faces. I want to say, okay, I want to go ahead, select this face and take these and maybe this face. Okay, I don't want these 2 edges, so I'm going to switch to select edge and take that edge off. I didn't take the whole edge off here, so dang. Let's do the same on this side. Okay, so we got, and see if 1 millimeter works. Okay, we have this 1 millimeter. Now I can try again. Now that we don't have 3-point connection here, we kind of switch. I can select these 2 and create another. Nope. Okay, that is a problem. Okay, we have 1 mm, so this 3-point connection is here too. So how about we take care of this now? Okay, we are going somewhere. Now take these two and make 1 mm fillet. Okay, finally worked. So we cannot make 2 mm fillets, but we can make 1 mm fillets. Now same as here, we have 3 lines coming in at one point, and couple of those are curved surface. So that's a challenging point for FreeCAD to make fillets. So how about I take this edge, the inside one, right? Make a tiny fillet, like very small 0.1 fillet. That kind of breaks it here. I hope nobody will mind. But now that's a problem actually. But can we make 2 fillets on these ones now? We can. We can, but this model is broken. So I decided I will not push any further. Let's keep it there. Let's say, you know, we did achieve the main part without the fillets. And that's end of phase 2. Let's see what else on this model. On here it says apply 500 Newton load to this face, and we fix these 3 cylindrical faces. Okay, it makes sense. And then we have plain carbon steel as our material. We can do that. Let's go into FEM, and in here we start with adding an analyzer and adding, okay, so analyzer already has solver in there, we don't have to add it, and adding a material, and we say plain carbon steel. Okay, carbon steel. I think that would be mild steel, but it doesn't have any mild steel in there, so we'll just take one of the generic steel, calculix steel, and we can see what the yield strength of this material in here. So the yield strength is not given. Maybe we should take something that has yield strength in it, say 1C22. It does have yield strength of 230 MPa, which is good. And so we got the material, and we go ahead and hide this. Okay, I want to fix this face, and that face. And now I want to apply a 500 Newton load on this face. So we go to this force load and add this face, and maybe reverse its direction. Okay, now if you see, okay, that was the horizontal line that we drew, so this is going directly downward, and we add 500 Newton. All right, the last thing is to add a G mesh, and I'm going to go ahead and go to first element order, which works pretty good for me, and hit apply. Give it a second, see if it works. All we are looking at the end, it says G mesh done in black, which is good. Okay, that's a pretty heavy mesh. Now what we want to do is go to Solver X and double click on it, write INP file, and it says FEM mesh has no volume elements, either define a shell thickness or provide a FEM mesh with volume elements. So our mesh did not work. This G mesh did not work. Too bad. Maybe we should try nmesh and apply. Okay. Now how about we go to Solver CCX and create the INP file and run calculix. And keep your finger crossed. We have our FEM mesh working fine. Let's take a look at the results. Okay, we will have it's not much of a displacement, 1 millimeter of displacement, so which is actually pretty small. So this displacement is coming at the end, which is expected, right? And we will have 60 MPa of stress, and our material strength was 230 MPa. So that's about 4 factor of safety, which is good. So that's a pretty good solid result. Okay, let me quickly go ahead and apply FEM, the same conditions on phase 1, see actually which model is better. All right, so I applied the same conditions for FEM analysis on the phase 1 of this model. Wanted to see how the difference is. So everything's same. Let's take a look at the results. So double click on the CCX result and go to displacement. If I remember correctly, this was 95 micrometer. Now it is 75, which makes sense because this is, okay, let me explain. These are the support condition and this is the cantilever arm at the end. And normally here is where the most moment comes, and at the end comes the deflection. So where the maximum moment is, the bending moment is, this model phase 1 is more beefed up in this area where the stress is maximum. It used to be here. So if we take a look at phase 2 CCX results, here we can see that the maximum stress is around this area at the end of the handle. So if we compare that with this one, so the maximum stress is coming a little bit at the near the end, because this where the maximum stress comes normally is a bit more beefed up with material, and that contributes to less deflection at the end. So it is like a very small amount of deflection, but this deflection is smaller in phase 1 compared to phase 2. And on the stress wise, we have 61 MPa of stress, which is around the same. So it was 59 on the other one on phase 2. Now it is 61. So stress wise, it is moving here and there, but kind of staying at the same place within that. But this actually gives a comparative analysis between two versions of the same model, where which one is better under certain loading conditions. And that's where actually FEM is applied more. Like, will the material break under stress? and is there any alternative design of the same genre. Anyway, hopefully you like this process of building this model, building a different version of it, and then doing a FEM analysis on both of those. So if you have any question, comment, or suggestion, please leave them below in the comment section of this video. Thank you for watching. I'll see you in the next video then.